here. So we have Not So Fashionable has 5 shirts and 3 pairs of pants. 3 shirts are striped and 2 are solid. The solids are green and yellow. The striped are essentially pink, green, or blue. The pants are yellow, pink, or blue, so Not So always picks random outfits. So in this tree diagram, there's not something where they can say, I'm going to wear it or not. They're going to wear a shirt. So their shirts are we have the shirts are striped and 2 are solid. So the stripes are striped and pink, striped and green, striped and blue. Then they have solid. So I'm going to say not striped and green and not striped and yellow. And then they have pants that are yellow, pink, or blue. Yellow, pink, or blue. Yellow, pink, blue. Yellow, pink, blue. Yellow, pink, blue. Yellow, pink, blue. So how many outfits does he have to choose from? So 5 times 3, 15. What's the probability that the outfit is pants of the same color as the shirts? That's what I meant to say. So pink and pink, there's 1. Green, not there. Blue and blue is 2. Green and not there. Yellow and yellows 3. 3 out of 15, or 1/3 probability. No, 1/5. What's the probability the outfit selected has green or yellow in it? This has green or yellow. None of those do. This one has, all of these have green in it, so they're all counted. This one has yellow in it. All of these have green in it. And this one has yellow and yellow and yellow. So that's 3, 6, 9, 10, 11. 11 out of the 15. What's the probability there's no green in the outfit? All of those have no green, so that's 3. All of these do have green. All of these don't, so that's another 3. All of these do have green, and all of these don't have green, so that's 6 out of 15. All right, number 2. Imagine there's a game where you draw a random card from a 52 card deck. Without replacing the card, then you draw again. What is the probability of getting at least 1 ace? So you're going to draw twice. So at least 1 is 1 minus the probability of getting none. So that would be no aces. So on the first, to get no aces, the first draw has to be something that's not an ace. So there's 48 cards that are not aces out of the 52. And if they don't replace it, then the second time I draw, there'd only be 47 that are not aces out of the 51 left. So we got to do 1 minus that, which is 1 minus 47 times 48 divided by, and I need to put this in parentheses, 52 times 51. And I get 0.149, or 33 over 121 if I do it in fractions. Okay. 3. Tossing 2 fair dice and getting a sum of 4 or doubles. One, two, three, four, five, 6. 1, 2, 3, 4, 5, 6. Sum of 4 is 3 and 1, 2 and 2, 1 and 3. Doubles are those. So I showed the sample space. Fill in the table. Getting both, there's only 1 out of the 36. Getting the second one doubles, there's 6 out of the 36 that are doubles. Getting a sum of 4, there's 3 out of 36. So this has to be 2 out of 36 that are not an X, but are an A. And not a, but not a circle, but an X. There's 1, 2, 3, 4, 5. 1 plus 5 is 6. And we have to get 36 out of 36. If there's 6 there, there must be 30 more here. And if there's 3 here, there's got to be 33 more here. And 2 plus 28 is 30, or 5 plus 28 is 33. So there's a table of not B. Not B is 30 out of 36. Or if B is these 6, the rest are not B. 30 out of 36. A or B. Well, there's 6 that are B, and there's 2 more that we haven't counted in A, so that's 8 out of 36. And these could be reduced, but I'm just going to get you the numbers here so you can see. E, A and B, there's 1 that's in both. And A given B, so of B, there are 6, and of those, there's 1 that's A. And if I were to ask if these were independent, I would have to know the probability of A without the given. Probability of A is 3 out of 36, which is 1/12. Not the same, so they are dependent. Just in case I asked that. Page 2. How many ways are there to select 4 students, president, vice president, secretary, treasurer, from a class of 30? So when we say we're giving them titles, we're arranging them. So we're going to do permutations, which is arrangements. 30 P president, vice president, secretary, that's 4, which is the same as 30 choices for the president times 29 for the vice times 28 for the secretary times 27 for the last. So that's 30 times 29 times 28 times 27, which is 6577 0, or we could have done 30 math probability NPR permutations of picking 4. You get the same number. Now, next one. $180 per policy, and each policy, and it has 600,000 policies. And it has this data for how much they had to pay out. How much was paid out in claims for $100,000? So if we just multiply each of these times 0.0002, we get 20. We multiply these, I think we're going to get 40. And let's see here, 50000 times 0.0008, 40. And this one, I think it's going to be 20 again. 1, 2, 3, 4. 1, 2, 3, 4. Yes. And no, 1, 2, 3, 4. Yes. And this one will be probably 12, maybe 120, but I'm thinking 12. Let's see here. 1, 2, 3 zeros is good. 1, 2, 3. 3 times 4 is 12. Yeah, $12. So if I went through and multiply that, let's check that last one. 12. Okay. So at the $100,000 level, I'm going to pay $20 per policy is what they're expecting. So 600,000 policies times $20 is 1.2 million. They're going to pay 1.2 million out for claims at the $100,000 level. How much money did the company make or lose? Well, let's figure out what the expected earnings or losses per policy are. So that would be this times this, which is the 20 plus the 40 plus the 20 plus the 12. That's how much they're expecting to pay out. They're going to bring in 180 per policy, but let's see how much this is. 40, 80, $92. They're going to pay out. They're going to bring in $180. So they're going to have an average expected value of $88 per policy. So how much money did the company make or lose? It would be 88 times the number of policies, which is $52,800,000, right? Yeah, 52,800,000. $88 they should make per policy times the 600,000 policies. Okay. Fox News has 900 registered voters, 19% Americans re-gift. Describe the population. So the sample was 900 registered voters, so presumably that is based on registered voters. That's what it would have to be in this poll. You have to be a registered voter, so that describes the population. Determine the type of study and explain. They're polling, so it's not an experiment, so it's an observation. Okay, and C, the margin of error. And for percentages, you take 1 over the square root of the size of the sample, which is 900. So that's 1/30th, which is 0.3033, which is 3.3%. So what's the smallest percentage that would regift? Based on this, it would be 19 minus 3.3, which would be 15.7%. 300 students were selected at the circ. 50 students opt out of taking the survey. Whenever you have a group opting out, you're having participation bias. If people don't participate in it, you have participation bias. Okay. And ask whether they consider themselves Republican, Democrat, or Independent. So what type of sample is this? This was a group that was at the circ, so it's convenient. And if we find the sample proportions margin error, we still can't have a 95% confidence interval. So they didn't ask us about this participation bias, and because it's a convenient sample, it's a selection bias. That's the two biases, and I didn't ask about that on this one, so I didn't need to write that. But find the sample proportions or margin of error for the confidence interval. Why we can't do that, I mean, we can say take the square root of 50 and 1 over the square root of 50 and do the percentages, but it has to be a random sample. And so the confidence interval is not going to be there. It has to be a representative sample, and usually a convenience sample isn't a real good representation, so we're not going to be 95% sure. We'll be somewhat sure, but not that high, because not a random sample the confidence interval is suspect. I'll just say that is suspicious. We're not sure we can go with it. Okay? Next page. CO2 emitted by persons, 7 largest producers, complete the table. Relative frequency, so we got to get the total. 15 and 15 is 30, 42, 43, carry the 4. 4, 5, 6, 7, 8, 9, 14, 17, 26, carry the 2, 21, 38, 50, 60, 78, 82. So we're going to do 19.18 divided by 82.63. So that's 23%. Relative frequency is done with percentages. Then we're going to bring that back and go 7 15.27. That's 21% rounded off. 12.29, which is 15% rounded off. 10.06 is 12% rounded off. 9.54 is 12% rounded off. 9.38 is 11%, and 4.91 is 6%. All right. Make a relative frequency graph. All right, we'll do that right over here. It looks like there's a little bit more room on this side. So on the bottom, I'm going to have the countries. And on the vertical is going to be relative frequency. And production of CO2 by 7 largest producers. And so we've got US, China, Russia, Germany, Japan, UK, and China. Making these all equally width, same spacing in between. And we have to get up to 23, so I'll go 10, 5, 15, 20, 25%. So the US has to go up to 23%. China goes to 21%. Russia goes to 15%. And Germany goes to 12%. Japan goes to 12%. UK goes to 11%. And China, oh, this is Canada, excuse me. And China goes to 6%. Okay, there's that. And then pie graph, how many degrees would Russia be? So Russia is 15% of 360 degrees. So we're going to take 0.15 times 360. It would, didn't do 0.15. That would be 54 degrees. If I put the point in there. Okay. Next one. 75 citizens over the age of 50 were given an anti-aging pill, and 75 were given a placebo. It was found the group receiving the aging pill exhibited slightly less degeneration in eyesight than the placebo. Determine the type of study. Well, that's A. This was an experimental. Because, and it says why. Because we have a control group and a treatment group. B. Determine what would have to be done to make the study double blind. Okay, so the citizens can't know whether they got the treatment or just the placebo. So that makes it blind on the part of the participants. They don't know who's getting what. And then the evaluators of the aging, when they evaluate, can't know whether the persons they evaluate were a part of the treatment or not. So they don't know who got it when they evaluate them, so they're blind as to who was treated or not, so they can only evaluate whether they have a better memory or not. 10. Describe a situation where you think there is a positive correlation that the correlation is not causal but has an underlying cause. So we just got to come up with something that has an underlying cause. So what would cause something to happen? Let's see. Let's see. Let's say something, the more tired you are, let's do this. So if you were more tired, the more you were tired, the slower your reaction could be. So the reaction time would increase if you were more tired. So the underlying cause, I'm just picking an underlying cause. More exhausted, tired, whatever. And so it would cause a slower reaction time, and it would also possibly make you less able to concentrate. So your concentration would go down and your reaction time would go up. So the reaction time would, your concentration is getting worse. So if you had fast reaction, you'd have high concentration, very short reaction times. So we'd have this negative correlation, and you would think this would kind of say, okay, the higher your reaction, the slower your reaction, the less you can concentrate. But the underlying cause is because you would have less sleep, more exhausted, would increase your reaction time. It takes longer to react, but it also would decrease how well you can concentrate. So that might be one underlying cause for these two to happen. So I'm looking for something third that's causing two other things to happen that might make a correlation, a graph that would represent the two seem to be related, but they might be related to something else causing both of them. Draw a misleading graphic and now draw a graphic that is misleading. Now draw one that's non-misleading. Describe what's going on here. So one possibility would be to say, okay, here's how much men can bench press. Let's say it was an average of 200 pounds. And the women were only able to do this amount, which might be 190. Which looks like there's a lot of difference. Okay, so now let's draw one where it's not misleading. So here's 200, and here's 0. So here's 100, and 190's here, so the men would be 200, and the woman 190. And it's saying misleading because this one doesn't start with 0. There's some left out. So it looks like there's a large difference, and here it doesn't look like it's such a large difference. Or you could do the ones with the different size dollar bills or the different size whatever. So where there's area involved, or the pie graphs where you got a large side showing and not representing the circle very well. Okay? And this looks familiar from our last test. In fact, I think this is the problem straight from our last test. So, how many times you got a 5? And out of 16, find the mean, mode, and median. So you'd lay them out there in order. Let's just do it. 0, 0, 1, 2, 3 ones, 2s, 1, 2, 3, 4 2s, 1, 2 5s. What? No, 4s. 1, 2 4s. Well, 3s. 1, 2, 3 3s. 1, 2 4s. And 1, 2 5s. Find the mean. So add them up. 3, 5, 11, 20. 8, 38, divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16. So I do have all 16. So 38 divided by 16 is 2.375. So this isn't the sample test or the test. The mode is, there's 4 2s, only 3 3s. So mode is 2. The median is the middle number. So there's 16, 1, 2, 3, 4, 5, 6, 7, 8. So it's right there between the twos. Medians are 2. 5-number summary. So Q0 is 0. Q1, Q2 we decided was 2, the median. Q3 is Q4 is the max, which was 5. So since this doesn't fall on a number, we use all 8. So 4 halfway between those, that would be 1 for the lower quartile. Here would be between these two, so it would be 3.5. Draw a box plot. 0, 1, 2, 3, 4, 5, Q2, Q1, Q3, and up to the max, down to the min. Fences, if I were to do the fences, the interquartile range is from 1 to 3.5, which is 2.5, always times 1.5 to find the fences. This is the interquartile range. That becomes 3.75. 3.75 above 3.5 is 7.25. And below 1 is negative 2.75. Down here someplace, so no outliers, just in case I ask that. Okay. Determine the standard deviation in the value where 84% of the data is expected to be below that value. Okay. %84% is supposed to be below that. So 50% is below the mean. If we go 1 standard deviation above that, we pick up another 34%, so that would be the 84%. So what this one here, I didn't really make this real clear, but 84% of the value there would be below the mean plus 1 standard deviation. That's what I was kind of getting at here. It didn't make it real clear. It's a question about this table. So sorry I didn't make that clearer. If 16 sets of dice are rolled in a random, which they are, what would be the mean value for getting sums of 5 in 20 rolls? And so we would say the mean value should be what we got, 2.375. And the margin of error would be 2 times the standard deviation. So what is the standard deviation on this? Oh, that's what I was supposed to do. This is referring back to this one here. So we got to figure out what this one was. So we need the standard deviation for this. So that calculation was a little bit lengthy. Let's do it right here. So we got 2 zeros. So we got 0 minus 2.375 squared times 2. And then 1 minus 2.375 squared times 3, and 2 minus 2.375 squared times 4 2's, and 3 minus 2.375 squared times 1, 2, 3 of them, and then 4 minus 2.375 squared times 2 for 2 fours, and 5 minus 2.375 squared times 2 fives. So we're going to figure this out. So I'm going to use my calculator here and do this a little bit faster. I'm going to go over here, clear list 1, clear list 2, clear list 3, and then I'm going to put in the 0, 1, 2, 3, 4, 5, and I'm going to do here, I'm going to do a formula on this. I'm going to take parenthesis, what's in list 1 minus 0.2 minus 2.375 close parenthesis squared, and oops, I'm missing something. Okay, I get these numbers, and then how many of these I'm supposed to do is 2, 3, 4, 3, 2, 2, and so in list 4 I'm going to take list 2 times list 3, and I get all of those. That's all these numbers. This one is going to be 11.281. Then we get 5.6719, 0.5625, 1.1719, 5.2813, 13.781, and now I want to add those up, so I'm going to go to, okay, quit, second list, operations, math, math, sum of list 4, that comes out to total 37.75, and so then I have to take, to get this, the standard deviation, I get 37.75 divided by n minus 1, 15. So divided by 15, and then the square root of that answer, and I get the standard deviation to be 1.58659. So if I take the mean, which was 2.375, and add the standard deviation, one standard deviation, 1.59586, I'll do 3 places here off of that, I get 1, 15, 16, 9, 3. So this is what I was asking for in this one, 3.961. Didn't make it clear that it was referring back to this stuff. So if we go the mean plus 1 standard deviation, 84% of the data will be below that. So now, what do we predict the mean to be for these dice? What we got in our mean for the sample. And the true mean is 2.22, so is it in the 95% confidence interval? So we have to take 2 times the standard deviation, 1.59, divided by the square root of the size of the sample, which was 16. So that's 2 times 1.59 divided by 4, square root of 16 is 4, and we get 0.795 that we have to add and subtract to that. 2.375 plus 0.795. The upper one is 3.17, and the lower would be that subtracted, which is 1.58. And is the 2.22 in the interval? Yes, it is. Okay. Recent poll of Washington voters, 2,500 randomly selected Washingtonians, 47 favor stronger gun controls. Determine the 95% confidence interval. So we'd take 1 over square root of 2,500. That's 1 over 50, which is 2%. If you work that out, it's 0.02 or 2%. And so it's somewhere between 45 to 49%. So which means that the population that favors, we think the average or the mean amount of population that favors gun controls is in this interval.